Assalamu alaikum, brothers and sisters. Welcome to the journey of quest where we quench your thirst of knowledge. Have you ever wondered how clouds move in the sky or why waves crash on the shore? This is where the fascinating field of fluid dynamics comes into play. Fluid dynamics is a branch of physics that studies the movement of fluids, both liquids and gases, and how forces affect them. This concept finds significant applications in understanding atmospheric and oceanic systems. The way clouds form, move, and dissipate in the atmosphere, the ebb and flow of ocean tides, the crashing of waves on a beach, all of these are governed by principles of fluid dynamics. Moreover, understanding these systems is crucial for accurate weather prediction, safe sea navigation, and effective environmental conservation efforts. It allows us to predict and prepare for severe weather conditions, navigate ships safely, and better understand the impact of human activities on our oceans and atmosphere. So, when we talk about the motion of fluids and waves, we are exploring the very forces that shape our planet. To start, consider this: what happens when you pour water into a glass? Now that's a simple everyday action, isn't it? But there's a lot going on beneath the surface. This is where the fascinating world of fluid motion comes into play. Fluid motion, or fluid dynamics, is essentially the study of how liquids and gases move and interact with their surroundings. Imagine the scene. You're pouring water into a glass. The water swirls and whirls, it sloshes around, it rises. That's fluid in action, and it's not just about water. Think of a gust of wind blowing through trees or a puff of air that you blow into a balloon. That's fluid motion too, because in the realm of physics, a fluid is any substance that flows, and that includes both liquids and gases. So when you pour water into a glass or when you blow air into a balloon, you're creating motion in the fluid. The water moves, the air moves. And that motion, the way it starts, the way it changes, the way it stops, that's what we study in fluid dynamics. But fluid motion isn't just about the small scale, it's also about the big picture. It's about understanding the currents in the ocean, the waves on the beach, the clouds in the sky, the wind in the atmosphere. It's about realizing that these vast, seemingly separate systems are all connected by the same basic principles of fluid motion. When you start to understand fluid motion, you start to see the world in a different way. You see the connections, the patterns, the beautiful complexity of it all, and it all starts with something as simple as pouring water into a glass or blowing air into a balloon. In essence, fluid motion is the science of movement, whether it's in a glass of water or the vast expanse of the ocean. Now, imagine the wind blowing across the surface of a lake. What do you see? You see waves, right? But what's really going on here? How does a gust of wind transform a previously tranquil body of water into a choppy, undulating surface? It's all about energy transfer. The wind moving air carries kinetic energy. As it sweeps across the water's surface, this energy gets transferred to the water, creating ripples and waves. These waves are not confined to the surface of bodies of water alone. They're also prevalent in our atmosphere, though less visible. Think about a flag fluttering in the breeze. The wind moving air is creating waves in the fabric of the flag. These are atmospheric waves, and they behave much like their watery counterparts. When we talk about waves, we're really talking about the propagation of energy. A wave is energy that's moving from one place to another. This is why waves can travel long distances. They carry energy across the oceans or through the atmosphere. In the ocean, for instance, a wave generated by a storm thousands of miles away can travel across the sea and crash onto a distant shore. This energy propagation is also why waves can have such a significant impact. When waves crash onto a shoreline, they can cause erosion. In the atmosphere, waves can affect weather patterns. They can push air masses around, causing changes in temperature and precipitation. And it's not just the natural world that's influenced by waves. They play a crucial role in our daily lives too. The flight of an airplane, for instance, is affected by atmospheric waves. These waves can cause turbulence, which can make your flight a bit bumpy. Waves, then, are not just phenomena we observe at the beach, they're all around us, influencing everything from the weather to the flight of an airplane. So, how do these two concepts, fluid motion and waves, intertwine? Imagine a grand ballet, where fluid motion and waves are the dancers, gracefully interacting with each other to create a magnificent performance. That's the spectacle we witness in our natural world every day. The first act of this ballet takes place in the depths of our oceans. Waves, born from the wind's friction against the water surface, interact with the fluid motion beneath. The result? Ocean currents. These are like large-scale river systems within the ocean, playing a pivotal role in distributing heat around our planet. The Gulf Stream, for example, carries warm water from the equator towards the North Pole, keeping Europe's climate moderate despite its high latitude. The second act unfolds in the atmosphere. Here, temperature differences create density variations in the air, leading to fluid motion or wind. When this wind interacts with the natural undulations in the atmosphere, atmospheric waves form. These waves are the unseen conductors of our weather orchestra, directing the movement of weather systems across the globe. But what happens when the dance intensifies, when the interaction of fluid motion and waves becomes more forceful? That's when we see phenomena like hurricanes, where warm ocean waters provide the energy for powerful winds, and the resulting waves can cause devastating storm surges. Climate change, too, is a testament to this interplay. As our planet warms, it disrupts the dance between fluids and waves, leading to more intense storms, changes in ocean currents, and shifts in weather patterns. Understanding these interactions is crucial if we are to predict and mitigate the environmental challenges ahead. So, the dance between fluid motion and waves isn't just a fascinating scientific phenomenon, it's an intricate choreography that shapes our world, from the currents swirling in our oceans to the winds gusting in our skies. By understanding the dance between fluids and waves, we can better navigate our world and safeguard our environment. So, what have we learned about the motion of fluids and waves in atmospheric and oceanic systems? We started our journey by diving deep into the basics of fluid dynamics. We discovered how fluids, whether gases or liquids, are in constant motion, governed by the principles of physics. We explored how factors such as pressure, temperature, and velocity can significantly affect the behavior of these fluids, leading to phenomena like turbulence and laminar flow. Next, we ventured into the vast world of waves, those rhythmic disturbances that travel through a medium. We understood how waves are formed, how they propagate, and the different forms they can take. We learned about the beauty of a simple ripple on a pond surface, the grandeur of a towering ocean wave, and the invisible atmospheric waves that play a crucial role in weather patterns. Then, we brought these two fascinating realms together, unveiling the intricate interplay between fluids and waves in our atmosphere and oceans. We saw how the motion of fluids can give birth to waves, and in turn how these waves can influence fluid motion. We glimpsed the intricate dance between the wind and the sea, leading to the formation of ocean waves. We witnessed the creation of atmospheric waves as a result of temperature and pressure variations in the air. Moreover, we realized how this interplay is not just an abstract science, but a living reality that shapes our world every day. From the gentle pour of a drink, governed by fluid dynamics, to the formation of cyclones and tsunamis driven by the interplay of atmospheric and oceanic waves, we saw the powerful role of these phenomena in our daily lives. And so, we can see that the science of fluids and waves is not just a theoretical study, it's a tangible, dynamic force that shapes our world, from the smallest droplet to the biggest storm. Whether it's the gentle pour of a drink or the raging waves of the sea, the motion of fluids and waves is a fascinating science that shapes our daily lives and our planet. Stay curious for our next upload. Till then, take care of yourself and don't forget to subscribe us.